Assalamu alaikum. As promised in the last video, today we shall show how to calculate density of states, that is DOS, and PDOS for a spin polarized system. Like the last video, we will also show how to save these calculation results in a different folder, and we will also show how to plot these results and save as EPS and PNG files. So let's start. Like before, the system I'm going to use is titanium carbide. So if I click in extract gen, you can see that I have no files. So if I use terminal, you can also see here that I do not have any files. So this is my working directory, like here you can see, but I have results for SCF calculation with the spin polarized system in a different folder. I saved it from previous calculation. So I'm going to use these results. So first I will copy here all these files. So now you can see I have all these files. So if I click now here structure, you can see the structure file shows, and I can visualize the structure also. Now let's start. So I'll click here and DOS. So since this is a spin polarized system, I have a spin up and a spin down. Let's first do with the spin up as it is selected. So first I will edit this one and use a higher Emax value like before, and I shall also generate a denser K-mesh. So I will use 5000. Okay, now I need to run LAPW up and LAPW1 down. Okay, now I need to run this one so that I can get the details about the available orbitals. So now it shows that I have all these orbitals, but I am not worried about these details because the script we are going to use will take care of all these things. I just need to run this one so that I can set the range. So I will click and execute. Now if you go here, that this is the file has been generated. So these are the range. This is the X range, the minimum value and the maximum value. If you need, you can change these values. Since this is for the tutorial purpose, I will leave them as it is. Now I need to run this one for also spin down. So I select here spin down, then I click this one. So this should be fine because I already have this file. Okay, now let's use the script. So if you go to the script section, you will see that the script number 12 to calculate and plot DOS and PDOS. Actually this is the last this is the same script that we have shown or used in this video, but I have updated it so that it can now handle the spin polarized calculation also. So let's use that script. So I have the script saved in this folder WIEN2k. I will use this one. I also have video here using external script. If you are not familiar how to use external script, you may watch this one. Okay, let's do that. So this is the script name. So if I click enter, it shows me that there are two atoms. One is titanium, another one is carbon. So I can choose any of them. If I choose 0, it will calculate the total contribution of these atoms. So first I will choose 0. So now this is the calculation results. So this is with spin down, this is with spin up. You can see the total, and that is the DOS, and the total contribution of titanium, that is PDOS, and also total contribution of carbon is plotted for both the spins. Also this is the total contribution, that is the DOS, for spin up and spin down. So this one is spin up and this one is spin down. it also plotted, this is for the titanium, spin up and spin down. This is for carbon, spin up and spin down. Now this range is different, so don't think that carbon has large contribution, because this range for titanium is -4 to 4, and for the carbon it is -8 to 8. Actually, if you see this one, so you can see from here the contribution of carbon is much less than the contribution of titanium in the conduction band, but in the valence band they are almost same. Okay, now you can get it shows that all the results are saved in the result.dos. So if I use another tab now, let me show you. So this is the folder has been created, so let's go there. So all these results are set. So these are the files. This one DOS1 EV up, that is the results that have been plotted. The datas are here. This is in the unit of electron volt, but you also have these results in read bar. So this is for the spin down, and the script, the new plot script that is used to plot is also saved. So if you need, you can modify it, you can change the ranges and whatever you can, like the title or the level, you can all modify all these things. I have a video that where I describe the basic things about new plot, and I showed this actually how to plot DOS and PDOS. But you may watch this one. You don't need to use the script that we discussed here, but that will give you the idea if you want to modify this one, so that you can plot as you like. That will give you all the explanations that needed. Okay, now we are going to use the atom 1 so that we can plot the contributions of atom 1. So we'll run the same script. Now we'll select the atom 1. So if I select atom 1, now it asks me for the choices of the orbitals. When you enter the choices, you need to put the comma between the orbitals, and how many orbitals you have for the system is given. If you click here, is given here. So in your system, the available orbitals that you can plot for PDOS will be given here. You need to check this one. Okay, now let's go here. So for the titanium, this is atom 1, I selected, atom 1 is titanium. I will use P, D, D, E, G and D, T2G. Okay, the total will be included automatically. So if I click enter, it shows that this command will be executed. So the total is chosen, and also all these things. So make sure that you type them correctly and put comma between them here, and you don't need to type total. Okay, now we need to confirm it. So yes, and enter. So this is the contribution of the titanium. This shows the total contribution of the titanium. That is the contribution of p orbital of the titanium, d orbital of the titanium, DEG and DT2G. So you can see here, so DT2G has the highest contribution. That is, this is almost the same as the total contribution. This is for the spin down, and this is for the spin up. So this is actually last plot. There is something more. Yes, these two also. This compares only the titanium with the total contribution, that is the DOS. Okay. So let's do that for oxygen also. So this time I will select atom 2 and for the carbon. So for the carbon, we know that there will be only S and P orbital will have enough contribution. So I don't need to go for others. Okay, let me choose D so that I can show you that. So again, I need to confirm it. So you can see now the S, P and D. D orbital has almost no contribution or no contribution. So the most of the contributions comes from P. Okay, all these results are again is saved in this folder as it shows here, result.dos. So now you have a lot more file, and the script that is used for plotting the graphs for the carbon is this one, and for the titanium is this one, and also the datas are here. So this is the data for the carbon, but these datas are for electron in the unit of electron volt. That the x-axis is in electron volts. Okay, and also for the carbon, all these things you have. Now we also have EPS files. Let me show one of the EPS files so that you know how it look like. So this is the EPS file. The advantage of EPS file, you can zoom in, so it doesn't fade. But for the PNG file, it fades out. So it is better to use a EPS file for your report or your publications. Okay, so I have explained you how to plot DOS and PDOS for a spin polarized system, and how to save these results, how to plot these results in EPS and PNG format. I hope this will be helpful for you. That's all for today. Thank you.